Now let's study about the different types of unit cells. Crystals can have 4 types of unit cells. The first one is called simple or primitive unit cell. It is denoted by the symbol capital P. Here, the atoms are present only at the corners of the unit cell. The second one is called the face-centered unit cell, denoted by the symbol F. Here, in addition to the atoms at the corners, atoms are also present at the center of each of the faces of the unit cell. The third type is called body-centered unit cell. The letter used is I. Here also, in addition to the atoms at the corners of the unit cell, there is an atom present at the center of the unit cell. And lastly, you have end-centered unit cell denoted by the symbol C. Here, in addition to the atoms at the corners, there are 2 atoms at the end faces of the unit cell. Now let's calculate the number of atoms in a unit cell. This is a simple cubic unit cell. It has atoms at all the corners. A cube has 8 corners and therefore there are 8 atoms in this simple unit cell. Even though this is how we represent a unit cell, the actual arrangement of atoms is like this. The atoms are packed much more closely together as shown in these 2 pictures. The atoms touch along the edges of the cell. Each corner of a cube, and hence each corner atom, is equally shared by 8 other unit cells. If you consider the part of the atom inside the unit cell, it can be seen that each atom at the corner contributes only 1/8 of its original volume to the unit cell. Hence, the contribution of one corner atom to the unit cell is 1/8. Since there are 8 such corner atoms in a unit cell, the number of atoms in a unit cell is equal to 1/8 into 8, that is equal to 1. Thus, for a simple cubic unit cell, the number of atoms per unit cell is 1. In a body-centered unit cell, atoms are present at the corners. We have seen that their total contribution to the unit cell is 1/8 into 8 equals 1. In addition to this, there is an atom at the center of the unit cell. This atom is not shared by any other unit cell, as you can see in these 2 pictures. Hence, its contribution to the unit cell is 1. Thus, the total number of atoms per a body-centered unit cell is 1/8 into 8 plus 1, that is equal to 2 atoms. Similarly, in a face-centered unit cell, there are atoms at the 8 corners which contributes a total of 1 atom to the unit cell. There are atoms at the face centers and each of this is shared by 2 other unit cells. Hence, the contribution of an atom at the face center is only half. Since there are 6 faces and hence 6 atoms at the face centers, the total contribution of face center atoms is equal to 6 into 1/2, that is equal to 3. Therefore, the total number of atoms per a face-centered cubic unit cell is 1 plus 3, that is equal to 4 atoms. In a net-centered unit cell, in addition to the corner atoms, there are atoms at the 2 end faces. Atoms at the end faces are shared by 2 unit cells. Hence, their contribution is 1 by 2. Since there are 2 such end face atoms, the total contribution will be 2 into 1 by 2 equals 1. Thus, the total number of atoms per an end-centered unit cell is 1 into 1, that is equal to 2. Let's summarize what we have studied just now. Each corner atom in a cube is shared by 8 unit cells. A corner atom therefore contributes 1 by 8 to each unit cell. An atom on the edge of a cube is shared by 4 other unit cells. An edge atom contributes 1 by 4 to each unit cell. An atom on the face center of a cube is shared by 2 unit cells and therefore it contributes 1 by half to each unit cell. An atom inside a cube is not shared at all. Now let's try to solve a problem. Consider a crystal made up of 2 elements A and B, where A atoms occupy the 8 corners of a cube and B atoms are at the body center. What will be its formula? The trick to solve this is to find out the number of A atoms per unit cell and the number of B atoms per unit cell. In the question, it is given that A atoms occupy corners of the cube. All the 8 corners of the cube are filled by A atoms. We know each corner atom contributes 1 by 8 to the unit cell. Therefore, number of A atoms per unit cell will be equal to 1 by 8 into 8, that is equal to 1. What will be the number of B atoms per unit cell? B atoms are at the body center. It is not shared by any other atom. So its contribution is 1. So the number of A atoms per unit cell is 1. Number of B atoms per unit cell is also 1. So what should be its formula? It should be AB.